Right. We are live. Hello, everybody joining in here. How's it going? We'll give it a couple minutes as people filter their way in. We'll get started a minute or two after 10:15 here.
Yeah, this should be an interesting one. I feel like I'm like I definitely think more folks joining this one will be interesting as well as we go through.
Yeah, definitely. Can also give a little bit of quick intros as folks are sort of making their way in. It's always a good way to spend the first minute or two. Um, I'll go first because I think mine's less interesting than yours, Amon. So I am John. I'm a developer advocate here at Arize. Do a lot of our kind of events, a lot of tutorials that we'll be putting out, a lot of the content, kind of just try to make sure to stay on top of all the new releases, try them out, see how they work with a lot of our different features for Phoenix and for Arize. So you guys have probably seen me on a couple of the materials that we've been putting out recently. And yeah, excited to talk through some of the O1 stuff. Amon, I'll let you introduce yourself as well.
Yeah. John, you're being way too humble, man. John for folks that are listening in, like John is absolutely crushing it across our entire community surface area right now. So yeah, major kudos to him on covering a ton, including helping out with a lot of the research that you'll see that we're going to cover later. So yeah, but for my introduction, my name is Aman. I'm a product manager here at Arize. So leading up our LLM tracing product line. So if you're working on LLM applications, feel free to reach out. Happy to try to help in any way that we can as well. Yeah, pretty excited to jump into, a little bit around what we're seeing around O1 and where the space is headed. And yeah, this should definitely be an interesting one. It's been quite a week for models in the last week.
Yeah, awesome. All right, I think we could probably get started. We'll probably have some more people joining in as we keep going through here. But yeah, so today, as you see, we're going to go through some of the O1 kind of material and release material that's come out from OpenAI over the past week or so. We're going to talk through kind of O1, what's been released. There's not a ton of kind of architecture things in there, so we're gonna sort of glean as much as we can out of some of the information that's been released. We'll show some of that stuff as well too. Talk through kind of the chain of thought side of things, some of the decisions made there. And then we've also done our own benchmarking and research testing out O1. So we'll kind of compare results that we got against some of the results that OpenAI released as part of their release materials. And then talk a little bit more about some of the industry effects that we kind of foresee with this. This is sort of a new kind of model in a way that's been released, or at least positioned as a new kind of model. So we think there'll be some kind of fun topics to debate at the end there as we go. As always with these kind of things, feel free to drop questions in the chat as we go. We'll try to answer those as we're kind of going through, just because it's always more fun when these are more of a dialogue, especially because this is all so new. It's kind of fun to have everybody jump in. So feel free to drop questions as we go, and we'll tackle them as we jump through. All right. So for anybody who missed it, back on the 12th, we had a release from OpenAI with this preview of their new O1 series of models. They've reset the numbering back to 1, as they said, because this is such a big leap forward in performance in some areas. So they're marking this as kind of a marquee release. So o1-preview and then a mini version of that same model have been released since the 12th. And the positioning of this is the models are really supposed to be very good at reasoning through complex tasks, solving kind of harder logical problems, math problems, coding, kind of these more problem-solving approaches, as opposed to just sort of text generation and things like that. So they're specifically focused towards that particular area in how they're positioning the models.
Yeah. I'll add as well, like it, there's a lot of speculation. They call it like a preview. They released mini. As far as I know, like we're still waiting on like the full release, which definitely should be pretty interesting as well to see if the capability is improving further with the full release. But yeah, it kind of feels like a functional proof of concept of this approach that they're putting out there and showing that this new kind of model architecture that basically has those improvements that you might expect to see on tasks that have like multi-step planning and reasoning. So yeah, interesting kind of call out there that it's like not the full model yet, just a preview.
Yeah. Yeah, I think we definitely talk more as we go too. I I feel like part of it is they want to see if people are going to use it for those sorts of use cases, and there's like enough of a split there because they're kind of dividing the use cases that this is really good for
Mhm.
explicitly, as opposed to saying like it's a sort of generalist model that can do a lot of different things and it might be better in this area. They're very explicit, like this is good for this sort of problem solving approach. So yeah, I mentioned things that they've positioned it's very good at in some of the release materials is reasoning and logic, kind of science, coding, math types of problems, especially like more difficult problems that, as Aman said, require some sort of planning forward. So being able to go through and plan out, okay, some examples they give are like creating a game, like creating the code for like a basic kind of game, and it actually will go out and plan what it's going to do, then execute on the steps, and then we'll do some kind of sort of working back through errors that it might have made. And it's using chain of thought to do, or a chain of thought approach to do a lot of this, which we'll talk about as we keep going too. The other thing that it's sort of touted as being very good at as a result of this is protecting against jailbreaks or other kinds of like attacks against it. So it's being sort of positioned as a very safe model as well. So talk a little bit more about that too. But that's kind of what's being put forward as the strengths of the model. And then it does have some areas where they say it's actually not the preferred model, which again, we'll talk about too, some text generation kind of things, some tasks there. It actually is less preferred than a GPT-4o. And then also because it's a preview, it is not supporting, or actually right now it's not supporting web browsing, like automatic web browsing and uploading files and images and things like that. We actually don't know if that's because it's a preview or if that's just a sort of function of the model. That might actually continue to be the case, but I would imagine they'll probably add those capabilities into it a little later on. But yeah, as you can see, this is an excerpt from the announcement that they released that it's missing some of these features, but they will probably add some of the web browsing and file kind of interaction in the future here too. And then I want to show the kind of part of the quick example video that they have here because it's sort of fun. I'm sure a lot of folks have seen this, and I'll probably go sound off for this so that I don't blow out anybody speakers, but you can see that the model itself is very good at kind of setting up some of the longer term coding tasks. So you can see in the example, they have somebody putting in instructions here to kind of go through and generate a game in this case. That's like a sort of just a quick little flash game, but you can see it's giving some detailed instructions here, saying what some of the images are and some things like that. But then the biggest thing with this model is that it basically, like when you put in some sort of request, it sits and thinks for a while and kind of crafts through the solution, and it can take kind of a long time to go through and create whatever that solution is going to look like. And then once it has sort of thought, it will go through and kind of execute from there, complete the generation. So you can see in this case, it thought for 21 seconds, and we'll talk more about this too, but you can kind of see it has this log of like, here's what I thought through, here's what I went through, showing some of those pieces there, which is sort of the chain of thought, but it's not exactly it. So we'll talk about that a little as we go too.
I think there's like a very like subtle hint as well in the text file as well, like the prompt that they show, which is the better description you give, the better output you're gonna get at the end of the day. So with this type of prompt as well, like I think you know, that's definitely kind of comes back to like how you prompt it, the level of detail you give, you know, the better result you'll get from the context going into the reasoning. So I thought that was an interesting, like, you know, like maybe like a subtle nod here to prompting still being really important in this model.
Yeah, definitely. And also, I mean, the longer time it takes to generate responses kind of, to me, makes it seem like something where you should spend a little bit more time like constructing, crafting the prompt, include a bunch of info there, and almost like ask it to do more in one iteration, as opposed to you. A lot of times I use that like existing models to do more like, okay, try this. Okay, now tweak it to be like this. Now tweak it to be like this.
Right. The quick iteration. Yeah, it's like it's like kind of like how people get used to like how Google queries or Bing queries sort of start to resemble a certain pattern, and like people stopped asking questions, they just type in the words and like get the top query results. Like it almost feels like prompting with the faster model starts to degrade to something like that. And now, you know, this is kind of showing like that's probably not the approach you want to take here. More likely you want to take a more detailed prompt, spend time on the prompt because it takes longer for an inference. So yeah.
Totally. Yeah, you guys can check out this this example as well too. But spool the code that they generate actually works out of the box and generates a little game for them, which is pretty cool. And then I see a question around how is it when you go to debug the code? Previous models get pretty messy. I guess there's maybe two versions of that question. It's like, does the code it generate work pretty well, or is it like having to debug it from there? I think anecdotally, I've seen it work pretty well for specific kind of setups. But then if the question is more like, how is it at debugging code that you've put into it to actually go and debug? I think I've tested a little bit with that, and it's been generally pretty good. It is slow, so like I don't use it in the same way as I use like a cursor combined with like Claude or something along those lines, because it is so slow in that case. But I admittedly haven't used it to like do a lot of live ticky-tacky inline debugging. I don't know if Aman, you've experimented with that more.
No, same here. I've like I have yet to really like fully integrate it in my flow as well. Like I still find like I get pretty good results from my flow with the faster model, faster inference, but maybe this is more helpful from like an architectural, it kind of feels closer to like the replit agent chain of thought approach than, where you want to maybe scaffold or start a task from scratch as opposed to maybe picking up something existing. So, and I think we'll talk a little bit and give some examples of that later as well. But yeah, anecdotally, I think it's definitely gearing towards that like cold start problem. Yeah,
it's a good question. And so I want to talk a little bit, like, again, they haven't released a lot of the architectural side of things, but they did release some info around the chain of thought reasoning approach and some things there. Basically just say they use a large scale reinforcement learning algorithm to reward the model for using chain of thought reasoning and kind of to get it to use that by default. They mentioned a couple things that are interesting here, which is that basically you get better model performance, even if you get better model performance by adding the ability to like train it more, basically increase the training time with this reinforcement learning algorithm. So the longer they train it with that, the better the model will perform. But then also the longer they give the model to think on each sort of query, the better it performs as well too, which is interesting. So it basically, if you up the time that it takes for the model to respond to you after you get a query, it's going to perform better, which is interesting to me that this doesn't tail off at some point, because to me, I feel like if you really like blow out the chain of thought and let it go as far as it wants to, I've seen cases where like previous models will kind of confuse themselves in a way and like will like loop back on things or like second guess and then go the wrong direction. And so it's almost like you had a window of how long you wanted it to go in that chain of thought. Whereas this is sort of suggesting that they can just blow it out as far as they want to, and it's increasing the performance of the model beyond that, which is I thought was interesting.
Yeah, I wonder what's truly going on underneath the hood for that too. Like, what sort of what that planning step or chain of thought looks like. If it's the chain of thought we know from the paper or some other approach that they've taken.
Yeah. I wish we had more info when it was doing
exactly right. Yeah. I must be. I don't know if it's unclear to me if it's exactly that algorithm or something else.
But yeah, for anyone who's not familiar, I think most folks in the call are generally probably familiar with the chain of thought. But the idea here is that you allow the model to think more step by step through things and kind of instruct it and position it towards planning out the steps it's going to take and continuing down that process, and then reflecting back on previous steps, examining the completion of each one to see if it's made some sort of mistake and some sort of mistake along the way. So the idea is it can kind of correct itself, think more step by step, as opposed to trying to like jump to the answer. It's been a popular technique for just generally improving model performance over the past probably couple of years, I would say. So it's always been a technique that some folks have used. You have things like the replit agent that have used it to more intensity as well. There's a bunch of examples within the release too that OpenAI put out, so you can see what some of this looks like. So like the coding one, for example, you can say, okay, over here on the OpenAI preview, I've got create a script, and then you can say, okay, show the chain of thought that the model went through. One that I actually really like is the first one. They have the Cypher one, where they're saying, okay, here's like this sort of text, and this translates the thing step by step, and then use that to decode this. And you can see there's a lot of info here, and it's kind of a fun one to read through in detail, but you can see this is sort of what the model is thinking as it goes through. This is the chain of thought that it follows. And so you'll see it will start to go through, okay, let me count the letters and see if there's anything there. Let me break them down. And then it starts to realize that that doesn't work in certain cases. And so it'll go down these paths, find a blocker, and then kind of return back up to an earlier part in the thought process, which is kind of cool. And
It even drops like idea, like there. This is an interesting, like, kind of, yeah. It is sort of interesting there. You kind of see maybe again like early sparks of something there, in terms of reasoning.
I love the it's like that didn't work. All right. But yeah, one thing that I thought was interesting with this too is like it sort of positions it and makes it seem like it's thinking like a human would think through a problem. But if you actually like read through this full example, you're going to get to a point in it where like it becomes really obvious to you how the cipher works, because you can recognize, I forget where it is. There's like a moment where it realizes that it should think of the letters in pairs, and then it doesn't realize that, or I think it's like maybe it doesn't realize that it should think of them in pairs, and it just doesn't compare the things in the right way. Anyway, I wish I had a better description of that, but there's basically a moment where you'll read through this, you'll be like, oh, it's really obvious what the cipher is, and then it still goes down another like bunch of different paths to figure out what it is. So it is sort of still like linearly problem solving. Oh, it's right here, actually. It's what it is. It's saying, okay, it's summing the letters, like the pairs of letters, and saying, okay, if I sum the letters, let's take the average of that, and that will give them the letter that they need. But they basically realize, okay, so we've got to get to T from O and Y. O is 15, Y is 25. So the sum is 40, T is 20. And so it's like, oh, let me try subtracting these things and let me keep going from there and test. And it tests out a bunch of different alternatives. You see like 4 or 5 alternatives there. When if you're a human reading through this, you pretty clearly immediately go, okay, 20 is half of 40. That's probably the average there. And you can kind of go from there. So I don't know. That was an interesting one to me. It's like it's thinking very linearly, but at the same time, it's almost positioned to think like it's to seem like it's thinking like a human would, but then at the same time, it still doesn't quite match the ways that a lot of people's brains would work. At least how I think of it.
Yeah, and again, who knows if like what's going into their chain of thought, if there's a max token that they're trying to hit or something, depending on how much time, if it's just producing more and more chain of thought there, to fill time, also could be something there, who knows. But definitely very interesting to get a peek inside, the ways that the model is thinking.
Definitely. I mean, on that note though, one thing that's kind of important to call out is that what we're seeing for the chain of thought is also not the exact chain of thought that it goes through. So there's a very interesting part of the release where they talk about the fact that there's a quote from the release, but they say that they want to have the model freely express its thoughts in unaltered form, partly because they want to be able to examine that for, and I actually have a quote here. They want to be able to monitor the chain of thought for signs of manipulating the user. There's a quote from there, which I thought was interesting. But they basically are like, we don't want to modify how it does chain of thought. We want it to do that sort of unaltered so that we can examine that and learn from that. But because of that, we can't train that chain of thought generation process. And so there might be things in the actual chain of thought that we don't want to show to users. So they show a chain of thought, but it's not exactly what's from the model. And it's a little unclear right now whether they're like using a separate model to actually modify the chain of thought output and then make that available for users, or if they're using another version of the same model, or there's something happening here where the actual chain of thought is translated into something that's useful for users and is a little bit more like sanitized. So that's something that's worth knowing, is that what you see when you use the model for chain of thought isn't actually the unaltered chain of thought. It's just a sanitized version of it.
But plus, like, I mean, even just to speculate, no way that this is like backed up by anything, but one speculation could be like that could be valuable training data as well, right? Like how to solve a problem and what their secret sauce is there, could be valuable IP to own. So sanitizing it could make sense for a few reasons. Yeah.
And to their credit, they do cite competitive advantage as one of the reasons they don't share it. So I'm sure that that's part of it.
Yeah. and there's a good question, which is how does model generate chain of thought? Is there another model that creates this chain of thought? How the user's prompts and feeds it back to the main model, or what's happening under the hood? Great question, Eduardo. The short answer is we don't really know. I don't know, not to speak for John on this one, John,
No,
if you
yeah,
have, but like you know, the truth is that we're basically consuming a like, you know, finished product that we aren't able to go in and like tear down and look at how it works underneath. We're basically we just have the results and our own anecdotal evidence of using it. But you know, OpenAI hasn't shared much around the architecture of the model so far. So yeah, we have the same question on
yeah,
our end.
yeah. And I don't know, this feels funny to me, this last sentence too, of manipulating the user. I wonder if that'll be something that we see.
Yeah, that's a big one in like the mechanistic interpretability space, and like eventually as these models get more and more, you know, get kind of capable, what they're able to, what their interaction with humans starts to look like is something that I think a lot of researchers are starting to monitor and keep an eye on. So it's like this is like cited as like a safety concern, I think, to have a that sort of, you know, sort of, you know, being able to inspect, are there any is there any like signs that the models might be you know, generating like some sort of like emergent properties that, you know, might be interesting. So
Yeah. All right. So then we have some evaluation data that OpenAI's put out. We have some of this and we have some of our own as well too. So we'll go through both those together and give you guys a picture. One of the themes here is that for like very hard problem areas, o1 is a much better performer than GPT-4o or previous models were. Like if you look at the math competition, the AIME, or some of the code force competition stuff, you see GPT-4o basically like couldn't solve a lot of these problems and would rank very low. And then o1 is now given this big boost. And again, we'll remind too that we don't have access to o1 as of yet. We have access to the preview of o1, which is the yellow that you see here. So apparently o1 is going to be even more powerful on some of these setups. And the fun thing is it starts to kind of outpace some experts, some human experts. So the AIME they talk about is a sort of math competition problem set. And basically o1 out of the box performs at a 74%. Or really 83 is probably the true alignment to, or the true result that I would get, because in this test you get 60 submissions per problem, I think it is, or 50 submissions per problem. So this 83 is probably closer to what it would actually get. But then if they remove that restriction of how many submissions you get per problem, that's part of this competition, then they can take it all the way up to this 93, which is among the top 500 students nationally. So this model's technically, if you remove that limit of submissions, the US Olympiad, which is kind of fun. So it's a very high scoring in that particular kind of problem set area. And then also, like you can see in the last sheet here as well too, that it surpassed human experts on this GPQA diamond problem set, which is kind of a PhD graduate level problem set that it goes through. They're very quick to say that that doesn't mean it's better than a PhD at all things or even these problems. It's just like in this specific example, it outpaced human experts. Yeah, I guess Aman, I'm curious for your thoughts on this. As like, is this a moment of, hey, now we have models that are surpassing human experts in certain areas, or does this just feel like we're picking individual things where it's better than human experts for like very specific kinds of tasks or tests?
yeah, I mean, I think if you look at some of the discourse online and like even their positioning of like, you know, compared to PhD level students, like we've gone from in the last 2 years, like high school to college to, you know, experts in the field, like lawyers, to now PhDs, which is like truly people who have spent like, you know, at least from a benchmarking perspective, a lot of time on a particular subject. So I do think that like the increase in the benchmark is interesting to see that the language around that. It's like the model is starting to be more and more positioned as you could have a PhD level scientist to help you with, you know, very specific, like imagine a fine-tuned version of o1 on like biochemistry or organic chemistry. You could have a PhD, you know, next to you helping you solve the task. I think that's what the product positioning of o1 is meant to be here. So yeah, I think like the scaling up of the benchmark is indicative of where they're thinking the use case would be. So
Nice. Yeah. Yeah. And there's actually, I think there's a part in there too where they talk about, hey, a bunch of benchmarks we used to use are no longer really valid because all the models we're comparing against have already outstripped these. So we're kind of like churning through different benchmarks that they use for as we have each new model release, which is interesting.
Yeah, I'm excited to get to the human expert comparison, or sorry, to the human preference comparison, because I think that is my that's the moment of what is going on here. So
yeah. Yeah, totally. So one more we'll show, of course, and then we'll get there, is that yeah, just some of the other kind of improvement we see over some of these other benchmarks like NLU and things like that that we used previously. O1 is kind of improving across the board when you look at these types of things. Again, these are very specific towards like problem solving in a lot of cases, and you can see things like the AP English Lang, for example, it's equivalent to the GPT-4o performance. So there are some areas where the increase from the model is actually much smaller, but then you have more, so call it logical problem solving, like the LSAT or physics or something like that, where you see there's a much bigger increase. So kind of going towards some of the human preference stuff, which maybe I'll just actually skip to here. It is interesting because there's certain areas where O1 is actually not preferred compared to 4o. So what we're looking at here is this chart is kind of comparing the outputs of 4o and the outputs of O1. For each of those two, basically, do humans prefer one or the other on different kinds of tasks? And so you can see that 4o is actually preferred here by a small margin for personal writing. So for like text generation or personal writing, humans are choosing the response from 4o more than they're choosing the O1 response, at least for this test they did. But then as you get to more quantitative and sort of logical problem solving kind of areas, then you're getting to more preference towards O1. So it is interesting. It's like, this is not just like, hey, this is a new model and it's better across the board. It is very much better at specific areas. And then there's still a slight edge for 4o in some areas. Like a lot of it seems to be around like text generation and qualitative kind of sides in that regard. But yeah, so it's an interesting result as well.
yeah, I think this for me was interesting because I think like it actually shows that I guess you could view this as, yeah, as like almost like a regression in certain tasks. Like, okay, editing text, it looks like it's about the same. Personal writing is a little bit lower, which again could be dependent on the task definition. But what is interesting is that to me is that the mapping of the other tasks of like mathematical calculation or programming, we'll get into. I think we should also hop to the coding one after this one. But the model can be better at coding, can be better at reasoning, but it almost seems like for like writing tasks or creative tasks, there's like a slight regression here, which is interesting that they're, OpenAI themselves is calling this out on this particular kind of subtask. So I think it'll be interesting to see as people use this more, does it even make sense to use it for things like creative writing or writing in general, as much as coding or reasoning. And I think I like wonder why that is, like, that to me to a certain degree, like why there's why it's only better at like tasks that seem to be more logical versus reasoning through something more creative as well. So
yeah
yeah,
I guess I mean, one thing that comes to mind too is that, I mean, you've got the error kind of bars here as well, and like there's a world where the personal writing is actually 50-50, it's like within that error range. And so
yeah,
I do wonder, is it that the model's improved generally, and then it's also very good at this sort of logical side, and so that like general improvement pulls it up more? And if you just use the same, like say they had used the chain of thought kind of reinforcement learning, this whole sort of technique back when 4o was released, would we have seen like much worse writing then? So I'm curious, like how much of this gap is if this is like a bigger gap that's being closed by just an improvement in training techniques, and say the next iteration of 4o is going to blow this out of the water from writing perspective,
totally. Yeah, yeah, that's a great point. Like it is within the error bars, so like for all we know, this is a little bit of like their data sort of being represented here versus like in actuality. But I just thought it was interesting to see like such a huge jump in some other areas and not a massive leap forward in others. So
Mhm.
Yeah. Uh, yeah, it's like what would a human prefer, I guess, in terms of writing? Is it like it's very subjective, you know, um, people's styles are different. Maybe that could contribute to this as well.
Yeah, that's yeah. And I guess I'll show the coding eval here too as
Yeah,
well.
this one
It's an
was
interesting one.
interesting because of the IOI as well. Like that particular benchmark as well.
Yeah. And if I remember right, I can check the thing, but the IOI is the fine-tuned version of o1, right? If I remember
That's
right from the reading.
that's what I'm like reading. It says
Yeah.
this model, yeah, it's like a um I'm trying to find the exact reference on if it's a fine tune or what sort of training was done
I
there.
should have included that in here, but I'm 90% sure it's like if I pull up the thing here, there's a further fine-tuning competitions, improve.
On that data set on the
Yeah,
yeah.
I believe that's what we're looking at here, but it's not 100% clear on what they show, but I think this is sort of implying that they've fine-tuned for the like at least programming competition problems. Maybe they haven't used specifically the code forces one, but
Yeah, they do
interesting.
drop. I'm like just a quick Google. They do drop like Code Forces has made their like submissions as well. Public, so you could go look at those as well if you're curious. Which is cool to see. Since it's like kind of crowdsourced. Um, so
Yeah. Uh, but yeah, I mean, I think one thing that's worth mentioning is that like if you look at code forces, they're hard coding problems. It's not like autocomplete your line, you know? So this is another area where it's like, yes, the models are very good for those, but going back to an earlier question, like you probably aren't going to use this to do autocomplete in your code because it just takes so long to do, or like to do minor edits to code. It's more like start from zero and like I got to solve a hard problem. Let's have the model try to figure out a path to doing that.
okay, so I did find the reference in the paper. It says they initialized from o1 and trained to further improve programming skills. So that's why I was like, I'm not sure if it's a fine tune or if it's actually like something else going on here. It might be something else going on here as well. So yeah.
It's
Um,
interesting.
based on that
Do you,
language, it's
yeah,
it seems a little bit more like there could be something else going on.
yeah. Do you envision that they're going to allow fine tuning for o1 like anytime soon?
Yeah, oh well, I don't know. I mean, I'm not sure about timing, but I would imagine that like the real I mean, this again kind of indicates that okay, training the model in some way,
Mhm.
adjusting the weights for a task like does improve performance, kind of a good selling point to take on some more workload from a compute perspective based on like
Yeah.
proprietary data. So if you had your business had its own, tasks where you wanted a, human level
Mhm.
sort of performance, like I can imagine you would probably want a trained model to help with that. So yeah, I don't know, and again, I have no idea what the complexity setup looks like. It feels like they're probably going to go tackle cost and latency next,
Yeah.
before they can go do training optimization. But yeah, that's since those two seem to be the biggest hurdles to usage at the moment. Um,
Yeah. Awesome. Before we jump into those, because we're going to touch on latency a bit in a second, there's a couple questions I want to make sure we cover. One is around is there equivalent temperature in the reasoning process? Are you able to kind of set a temperature parameter to free up the creativity of the problem solving? I don't believe that there is an ability to set temperature. Actually, I see Matthew jumping in as well about mentioning the same. Yeah, I don't think that you have any sort of temperature parameter that you can set for o1, which is new for this model. Like you've been able to set that for 4.0 and on previous models. So they're limiting that in some way, at least for now.
Yeah. They basically, I mean, even if you go look at it, there's like a little bit of helper text in the playground from OpenAI. It says system instructions and model configuration are not available yet. So they haven't even allowed you to like set system prompts or yeah, exactly.
Yeah.
There's really nothing that you can do there, as Matthew says. Like basically it's just the message in the model.
Yeah. Uh, which I mean, it could the way that they're positioning that though, it could be that it's a more fact function of being a preview versus being like a capability
Totally.
that won't exist in the full release too, though. It's worth
Totally.
mentioning.
I have a feeling this was sort of like a little like we can get into it but in a bit of like the once we get into like public perception, but I do have a feeling this was like a bit of a equivalent to like ChatGPT sort of test to see like what people would use it for, how people would use it, so that they can determine, their own investment here as well.
Mhm.
So yeah, it feels like a beta to me.
Awesome. And then there's
Uh,
another question we had too.
yeah.
What is your measure on the level of breakthrough here? Is this considerably more groundbreaking than taking your favorite LLM, creating an agent that's told to take a deep breath, break down the steps, and then executing and analyzing the steps of each step task? Um, I'll share my take because we've actually done a bunch of agent building over the past few weeks. Um, I don't know that the performance is going to be like, I think if we had built an agent that was specifically going to do like, let's say the code force problems, and we set it up to do that, we could have set up something that was going to have that level of reflection and like chain of thought and added those pieces in. To me, the biggest thing is that now I've got a model that will do all of that out of the box. And maybe this is jumping ahead to some of the industry effects, but to me, it's like, okay, now I could just use o1 to do that as opposed to spending a few hours trying to code and pull together an agent that has all those extra pieces to it. So I think that there's my perspective on the breakthrough here is that it's going to make it easier to use models out of the box for more complicated tasks and not have to cover that ground with extra tooling that you have to set up yourself. But I guess, yeah, I don't know to me, it's not like we've now blown the lid off of AGI. It's just like we've removed a lot of the extra stuff that you have to do and bake that into the model itself.
Yeah, I mean, I think it's like the argument is that, okay, you have like a really good like LLM like substrate layer. This is sort of the like, maybe getting closer to like an application layer above that, which is moving reasoning closer to your LLM API or to your model level layer, as opposed to you having to go and tweak the system prompts or agent prompts to do, as you're saying here, like take a breath, or okay, maybe it's not take a breath, it's take a pause. Like, who knows, like what the impact of those like random tokens are on the overall performance. I feel like it's the goal, like the argument, to be made in favor of o1 is to move that reasoning a little bit closer to the model layer and just have that optimization happen underneath the hood. But yeah, that's just a speculation.
All right, I'll keep it going because we only have a few minutes left,
Yeah.
actually. But yeah, one other area is the safety side of things. So with this, they also tout that the model's much better at detecting harmful prompts and preventing jailbreaks, which I think is also an interesting area. This is sort of the same theme of like the model's doing things that you previously had to build extra tooling to do yourself. So if you're detecting jailbreaks, maybe this is an indication that the model can do some of that for you instead. And so you could kind of maybe guardrails or something that you can do in slightly less of a degree because o1 is pulling that kind of thing in. But it makes sense that the kind of reflection and the fact that it goes through each step multiple times gets better at detecting things that try to sort of sneak through it in some way. I also have to imagine though that there's some element of like existing jailbreak prompts are partly tuned to certain models. And so give it a few weeks and we'll have some people who will have created more o1 specific jailbreaks and this number might actually go down.
Yeah, good point. Like, who knows what a jailbreak for this type of model looks like? Could be very different.
And then I want to share some of the benchmarking we did as well too, just because this is all we so far we looked at OpenAI's like announced kind of things. We basically did a whole research thread that we'll link as well, but I'll kind of summarize as we go through here. Where the hardest eval that we do typically is this time series data set evaluation, where basically we have 100 different time series data sets, and then or a few more than that actually. And then each one of those has some metric graphed over time for a world city. So like imagine like temperature in a city is one metric, and we have that over time. And so you have a big JSON object of all of these different metrics. And then we have an LLM go through and try to detect anomalies within that. And it has to split that down to like specific metrics. It has to split it down to specific cities that those metrics are relevant to. And it also has to kind of do that all across these different instances, essentially. So it's a very difficult task for most models to do. We also did some kind of varying of context length, which we'll show too. And then we actually made this even harder by making all of the data points fractional. So they're all 0 to 1. And we sort of like brought them all into that range, as opposed to having broader members. So this kind of time series analysis is something that we actually do in real world use cases in our Copilot agent that's built into the Arize platform. So this was a real world thing. We were kind of testing, okay, can we use this O1 to improve the performance on that type of eval? If you guys scan the QR code on the bottom right, we have some of the traces, so you can go actually see the traces of each of these evals run, which is kind of fun. So you thought those links on the bottom will take you towards that if you want to check out what that looks like. Here are some of the results that we saw. So previously the best one we had was 3.5 Sonnet, which basically like each of the red boxes here is a missed anomaly. The greens is a detected anomaly. The sort of neutral is neutral. And then there's some false positives in there as well too. So Claude Sonnet was the best one we had tested earlier this year. It found 60% of the anomalies. o1-preview found 100% of them with one false positive as well. So it actually did a lot better across all the tests that we ran. o1-mini doesn't do as well. So that's an interesting note as well too, but we did see a huge performance boost here from o1-preview, which is pretty cool. It actually was able to kind of go through and create that performance boost. There's more detailed results that we have as well too of going through different context lengths and things like that. But you can even see on the longer context length one at the top here, o1-preview still finds almost all of the anomalies. It misses 3 in this case. So even at the higher context windows, it also still performs very well. o1-mini did not perform very well, which is interesting. It was not up to the same level of performance.
Yeah, who knows what layers dropped out with mini, but yeah, this was a really interesting result. It's like definitely, I mean, it kind of can persuaded us that like, okay, maybe mini's not, yeah, definitely not as capable as a preview at some of these tasks. So
and so I mentioned like this is a real world use case. The other thing to note here though is that each of those run-throughs took like 2 to 3 minutes. So the latency is like a real concern here. Not concern, I'm sure they'll improve the latency over time, but it does mean that like for our case, it's a Copilot agent in our dashboard. We can't really sit there for 2 minutes or 3 minutes and just have it spinning thinking. And so there is some element of latency where like this is kind of geared towards these more almost offline tasks where it's doing reasoning and you're not like getting a user experience on it. So we're not pulling in O1, as far as I know, we're not pulling O1 into Copilot as a result of this, but we're definitely going to keep paying attention to it as they try to improve some of the latency over time here. Yeah. So yeah, I guess we have a couple minutes left. I kind of jotted down some of my own takeaways or discussion areas to think about, but I wanted to kind of summarize my own takeaways from this, and then we talked through some of the questions. But one of the big things is that to me, like now we have a kind of new state-of-the-art model for these logical offline instruction kind of tasks. So if I have a very hard task I need to do with that, O1 is going to be the one that I go to. All of the evals that we've seen other folks running to kind of back up that the performance is there, even though the latency is not there. And then you might have O1 and o1-mini becoming models for code copilots over time. But again, that latency becomes a big issue that you have there. So you need to have latency kind of come down on this before it's used in any kind of like user-facing products as well. But yeah, Aman, I guess, are there any other takeaways in your mind of like the top line you're coming out of this with?
Yeah, I mean, I think I tend to look at like how people use the model, like what the reception is, what the our own testing is, and then our own like anecdotal uses. So for me in those 3 areas, like I mean, the reception does generally seem to be that this model is better at, tasks that require planning, tasks which this actually comes back to one of the first slides, which is like, the more context you give the model, the better it'll be at planning. And so it's actually a little bit, there's an optimization there of like the time you spend on the prompt to get a better result. And then I haven't yet swapped it out in myself for coding and like cursor, but I'd probably try that and see. But anecdotally, I think some folks are saying like it's better than 3.5 Sonnet, but some people say like Sonnet is just amazing. So like, so yeah, a little bit unclear there just yet. Yeah, I think like this definitely is a hint in like the direction that this next series of models is going to go, which is you know, more capabilities, maybe more training abilities as well on specific data. So you have like a PhD sitting next to you or something like that. But yeah, the latency is brutal right now for like any sort of usage. Um, I don't know. There was a benchmark that we'll throw up in the links as well. This is like an anecdotal result of like, you know, some of the Gemini's, like the latest Gemini model that just launched, I think, yesterday, or maybe it was the day before. 1.5002 beats o1-preview in a couple of tasks as well, like in math. So for like much, you know, significantly lower cost and latency. So it is, you know, I think maybe we even have to start rethinking some of the benchmarks here. Like maybe it doesn't make sense to use some of these models for solving, you know, basic problems and actually just reserve them for more complex ones.
Yeah. Yeah, the takes of like the model routing companies will be interesting. Like I want to see if there's some element of these models being like baked into model routing, like Martian or something like that. And then yeah, I definitely want to get Cursor to use this as my composer model when I'm trying to do like, okay, let's start a whole new file. Like, this would be great for that in my mind. So I'm excited for that to come through.
Totally. Yeah.
Unfortunately, we are at time here, I think. So I'll wrap it up there. A lot of exciting stuff coming there to see. Excited to see the full release of o1 coming through. And yeah, those should be good over time. As always, you guys haven't tried out Arize or Phoenix, use these QR codes here. Phoenix is our open source tool. You can go use that QR code, give us a star if you're feeling magnanimous today. And then you can always sign up for a free account on Arize to test this out as well too, and test out some of that Copilot that we showed, which is fun.
Yeah. And I'll plug if there's any papers you would want us to cover as well, feel free to drop them in our Slack community. You know, something you would like to see covered. I'm happy to do that. Times we can even bring in like paper authors. So would love to cover what the community wants to see next.
Awesome. Yeah, and with that, thank you everybody. Have a great rest of your day.
Thanks.